Hi there. Today I'm going to be talking about exponents. We're mostly going to be talking about exponents of 0 and of negative numbers, but we're also going to be doing a little bit of review talking about positive exponents, and hopefully that should be some review. If not, if the terms that we're talking about today are unfamiliar, go ahead and look up the rational exponents video that I have already posted on YouTube. Many of you have already seen the way exponents work. When we have a positive power, the base is simply multiplied together as many times as we have the power. So for instance, I have 4 to the power of 3 here. So since my base is 4, 4 is the number we're going to be multiplying together. And since my power is 3, we're going to multiply it together 3 times. So I have 4 times 4 times 4. When we calculate this out, all we're doing is simply multiplying them together the way we normally would. So, for starters, we would do 4 times 4, which gives us 16, and then we bring down our other 4 over here, and we do 16 times by 4, and we get 64 as our result. So, 4 to the 3rd power is 64. If I write out all of the powers of 4, there should be a pattern that we notice. So 4 to the 4th power, if you calculate it out, is 256. Now if I take 256 and I divide by my base of 4, I'm actually going to get 64. So 256 divided by 4 is 64. If I continue this, if I do 64 divided by our base of 4, I'll get 16. And if I take 16 divided by 4, I get 4. And this will let us calculate what 4 to the power of 0 is. And if you follow this pattern, you should find that you get 1 here, because 4 divided by our base of 4, well, anything divided by itself is just 1. So we end up with a 1 right here. And in fact, any number to the power of 0 is going to be 1. If I have 7 to the power of 0, it's going to be 1. If I have 20 to the power of 0, it's going to be 1. If I have 700,000 to the power of 0, it's still going to be 1. So no matter what, you always know that anything to the power of 0 is always 1. Now, we're actually going to continue using the same pattern to figure out what's going to happen with negative exponents. So if you're feeling comfortable with what we've been working with here, try pausing the video and determine what 4 to the negative 1st power and 4 to the negative 2nd power are going to be. Alright, I have left up 4 to the 1st power and 4 to the 0 power, so if you continue the chart in your notes, you just have to, you can keep it on the same line. But if we take a look at 4 to the negative 1st power, well, if you use your calculator, you would do 1 divided by our base of 4 in your calculator, which is probably going to come up with 0.25. Now, if you convert this into a fraction, that's going to be 1 over 4. And that's the same thing as 1 over 4 to the 1st power. So notice here, we have a negative 1 for our power for starters, and then we end up with a positive 1 in the denominator here. The same pattern is going to happen down here. If I take 1/4, or 0.25, divided by our base of 4 once again, if you do that in your calculator, you're going to get 0.0625. Now, if you convert that to a fraction, that's actually going to come out to be 1 over 16, which is the same thing as 1 over 4 squared. So we started off with a negative 2 for our power, and we ended up with a positive 2 in the denominator. And this is generally the way it works. If we have a positive whole number raised to a negative power, all we're going to do is take that number, move it to the denominator, and change the exponent to be positive. So we started with 4 to the negative 1, we moved the 4 to the denominator, and we changed the exponent to be positive, so it became positive 1. Same thing here. We have 4 to the negative 2nd power, We moved the 4 to the denominator, and we changed the power to be positive. If we start with a fraction and the denominator has a negative exponent, things are a little bit different. So instead of moving things to the bottom, we just move it to the top. So here we have 5 over 2 times by 3 to the negative second power. Now 3 is the only part that's raised to the negative second power, so that's the only part that's going to move. So we move the 3 to the numerator, and we change our exponent from negative 2 to positive 2. That's the only thing that moved because it was the only thing up here that had a negative exponent. So now all we have to do is calculate this out. So 3 to the second power is 9, because 3 times 3 is 9. I multiply 5 times by 9, and I get 54 over 2. With the second example over here, you see we have some variables thrown in, but this doesn't really change anything. All we're going to do is 7 to the negative first power is the only thing with a negative exponent, so it's going to be the only thing that moves. So since this is in the numerator, it's going to move to the denominator, and I just wrote 7 here because 7 to the first power is just 7. And the a squared stays on top, and the a and the 3 stay on bottom. Now all I'm going to do is I'm going to multiply 7 times by 3, which gives me 21, and then I'm going to simplify by canceling out one of the a's on top and the a on bottom. So I end up with a over 21.